Greetings everyone, you're watching Nerichem. This is question 3 from the HSC 2018 paper. An esterification reaction is to be performed. Which of the following substances, when added, would increase the yield of the product? Well, I would say in order to think about an esterification reaction, we should probably draw one. Vinegar we add to our salads. Now, vinegar is just ethanoic acid, which I have drawn on screen. When added to ethanol, which is the alcohol which we consume, we generate ethyl ethanoate and water. Now, when talking of the yield of the product, we apply Le Chatelier's principle. This should be the first thing which comes to our mind. But I'm just going to take a moment to make things more intense than they need to be. I'm going to draw the reaction mechanism for no reason. So we have a lone pair which attacks a proton, which comes from the sulfuric acid, which is the catalyst for this reaction. Because it's a catalyst, I've drawn it above the reaction arrow, which shows that it is regenerated. When we attack the proton, we get a positive charge on the carbonyl oxygen, which of course is unstable, but it is in resonance with other species. Now, the lone pair from the ethanol oxygen attacks the carbonyl, and we neutralize that positive charge. This generates a tetrahedral species, which again is itself quite unstable. And of course there is a positive charge on the ethanol, which has donated its lone pair. And here we have the other hydroxyl group. Now this will undergo a proton transfer, which I will write as plus minus H plus. This just means that I'm moving the proton from the alcohol group to one of the hydroxyl groups. This produces the species which I'm drawing currently. Now this is fundamental to the mechanism. If you don't do the proton transfer, you won't get the end product. What happens now is we reform the carbonyl bond and we expel the water, which gives us our final product. And please notice that this hydrogen here we have generated, and it is the same proton which was taken from the sulfuric acid, and it is regenerated at the end, proving that sulfuric acid is indeed a catalyst. Great, now we can answer the question. We have all the information we need as far as the mechanism is concerned. We need more information though. So water, what would water do? Well, following Le Chatelier's principle, water being on the product side would increase the concentration of the reaction of the reagents, which are on the left-hand side rather, which does the exact opposite of increase our yield. In fact, it decreases our yield, so it cannot be water. I will skip to D for a specific purpose. We have the dilute sulfuric acid. Now, catalysts will increase the rate of reaction, but they will not necessarily increase the absolute yield of a product. So we know it cannot be the dilute sulfuric acid. It would just make it either go faster or slower, but the yield in infinite amount of time would not change. The boiling chips and more alcohol, as they say, are a little bit more controversial, and they're controversial if you really think about the question. If you're not really thinking about the question, it becomes a lot less controversial. Boiling chips are added to smooth the boiling process. So I have a test tube with a liquid inside, which in this case is my reaction. I've drawn a flame below, and the liquid is bubbling and boiling, and it boils so vigorously that the liquid leaves the test tube, and this is called bumping. Bumping. Now, if you add boiling chips, which I will draw in black, the boiling process becomes a lot smoother, and this bumping does not occur. So technically speaking, if your bumping was vigorous enough to make you lose liquid from your test tube or your reaction vessel, whatever it was, then you would technically decrease the yield of the product. Now, this means that it cannot be the boiling chips. So we have one final option, which is adding alcohol. Now, when we apply Le Chatelier's principle, we see that alcohol is on the left-hand side of the equation, and we see that increasing its concentration would increase the concentration of the product. So we know that the answer is C. Good. Thank you very much for your time, and I will see you next time.